All right, in this video tutorial, we're going to talk about the Big Ideas Geometry section 5.5, Proving Triangle Congruence by SSS. And SSS stands for side, side, side. So you can use the side, side, side congruence theorem. Then we're also going to briefly talk about the hypotenuse-like congruency theorem, which is specifically for right triangles. So the side, side, side theorem says that if you have three sides of one triangle that are congruent to three sides of a second triangle, then the two triangles are congruent. You don't need any angles of the description of the triangles to be congruent, as long as all three pairs of sides are congruent and they are corresponding to each other, then you can write a congruency statement. So notice how in this example, even though the triangles look like they're mirror images, your corresponding sides are AB and DE because those are the ones that have the one dash mark that are congruent. BC to EF have two dash marks. AC to DF have three dash marks. So those are your corresponding sides, and you can write your triangle congruency statement of ABC to DEF. Okay, so here is how we can use this information to prove two other triangles are congruent to each other. So given our two-column proof, we're going to put that first given information into our statements. So we're given the first statement as KL is congruent to NL because it's given. The second one is KN to NM is congruent because they are given. Again, when we start going over some other types of triangle congruency theorems, it's important to know which ones are our sides and which ones are the angles. So for right now, we're just going to make sure that we put an S next to our sides. And once we get all three sides, then we can prove it. So we need to find our third side. And notice that these two triangles are bumped up next to each other and they share the same side of LM. So we're going to use the reflexive property of congruence to say that LM is congruent to LM. And that is your third side. So now you can write a triangle congruency statement so long as all of your sides are corresponding to each other, which is what this prove statement is right here, always goes at the end. KLM is congruent to NLM by side, side, side. All right, explain why the bench with a diagonal support stable, while the one without the support can collapse. So here's a couple different ways we can approach this. So the bench with the diagonal support forms two different triangles with fixed side lengths. That bench is not going to be moving as long as that hypotenuse triangular support beam is going diagonally across the bottom. So by the side, side, side congruence theorem, those two triangles cannot change shape, or they're not going to be changing distances of those beams that are underneath the bench. So the bench is stable because the sides are not going to change. And the other one, it could wobble back and forth, and that these vertical beams right here could change. So if it doesn't have that diagonal support, there's a bunch of different side lengths that you could get within that quadrilateral. And those angle measures are going to change within that bench. So because those two triangles are not going to change any side lengths or any angles, that is a fixed object that is not going to change at all throughout any movement. So hypotenuse-like theorem specifically talks about right triangle congruency theorems. So anytime you have a right triangle, you have to have a right angle, or that little red square in the corner of one of your triangles. So the two sides that are touching your right angle or adjacent to your right angle are called the legs. And then the longest side, or the side that is opposite of your right angle, is called the hypotenuse. So if you have the hypotenuse and one leg of a right triangle of a congruent to the hypotenuse and a leg of a second triangle, then the two triangles are congruent. So in this diagram, notice how your AB is a hypotenuse, DE is your hypotenuse. Those two things are congruent. All you need is one pair of legs to be congruent in order to say that the whole triangles are congruent. I know in SSS you need three sides, but if this is specifically a right angle, this is the only shortcut for side, side, side that you can use. So let's write a proof using this. We're given that WY is congruent to XZ, WZ is perpendicular to ZY, and XY is perpendicular to ZY. So let's redraw the triangles, separating similar to some other examples that we've done by splitting them apart and they're not overlapping to help identify the angles and matching up the corresponding parts so that we know which side is which. Then we're going to mark that given information. So WY is congruent to XZ is that first one. Or given that these two sides are perpendicular, which means that they're going to form 90-degree angles of perpendicular sides. And same thing over on the other triangle. So let's go to our two-column proof. Write our given statements. You should have 3 given statements. That first one is your hypotenuse. So you're given that the hypotenuses are congruent. Then you're given that perpendicular information so that it's a right triangle. And based on the definition of your perpendicular lines, you can say that those are right angles. And those two triangles are right triangles because you have a right angle. So then your reflexive property back in the first diagram that shows the two sides that are overlapping each other, ZY and YZ, those are your sets of legs that are congruent to each other. So by writing that description, that is your leg. So notice how the labels on the left, you have your hypotenuse and leg. And based on the HL congruency theorem, you can prove that WYZ is congruent to XZY.